Hello everyone. In this first course on probability and statistics, we're going to be focusing on tables and graphs. Let's start off with a few definitions and an introduction to data presentation. Okay, so these are just summary words that we use throughout the descriptive stats section. Descriptive stats themselves are techniques, tools, methods that we use to summarize, organize, and present data. Statistics are methods that are used to collect, organize, analyze, and interpret numerical information from data. Inference goes a little bit further because these are methods that are used to extrapolate information about samples in order to make predictions about a population's behavior. The individual is the statistical unit from which qualitative or quantitative data is obtained. An individual doesn't have to be a person. It could be a house or a region or a country. A population consists of all individuals, whereas a sample is the subset of individuals taken from a population. We're going to be examining variables quite a bit, so aspects or characters of an individual that is being studied. Here is what a data sheet will look like in general. First thing you should observe is that every row of the data sheet gives you information about an individual, and for each individual, information was collected on a different set of variables. All rows put together create the sample or the population, and the columns themselves present the information or the collected values for the different variables that were in our study. Qualitative variables are non-numerical or categorical sets of data. Qualitative data can be split into two types. There are nominal variables, so qualitative data whose order is completely irrelevant, so the type of fuel, Seja program, store department, eye color, etc. Qualitative data can also be ordinal, which means even though it's qualitative, so non-numerical, the order does have meaning. So degree of appreciation, the diploma that was obtained, your military rank, are you an officer, are you a lieutenant, etc. So these are all names, but with order meaning. Quantitative variables are all the variables that consist of numerical measurements. So again, quantitative data can be split into types, can be discrete, where numerical data have a set of values that are finite or countable. Number of children, years of experience that were completed, number of rooms in a home. Could be continuous, when the numerical data can take on countless numbers of values in intervals or along a line. Back to a data sheet. So here we have information that was collected about clients of a cell phone service provider. Notice how within the collected data there is nominal data, so the type of operating system that is used on the phone. Okay, so there's no order, or there's no meaning to the order. Android, Mac, Google are just names. Whereas the diploma that was obtained is ordinal data. So we would expect someone with a high school degree to perhaps have different characteristics in terms of cell use than someone who has a PhD. Quantitative data can be discrete. In this case, the number of people in the household is discrete, and can be continuous, where we have the cost of the cell phone plan. Of course, in practice, we have to round to the nearest cent, but the different amount of possible observations is so big that we treat it as a continuous variable nonetheless. We use frequency tables to summarize the data that was collected, whether it be for the results of discrete variable or group continuous variable, and actually even for nominal and ordinal qualitative variables. A frequency table can be useful as well. It should consist, or it should present, the number of observations for each value and for the sum, as well as the relative frequency and the cumulative relative frequency of the observations. So that means that essentially the content of the frequency table should have the count, so the total number of individuals who were surveyed. We use little n when referring to the sample size, or big N if the table actually presents population data, and big N would be the population size. The frequency is the number of times a specific value or observation or class has been counted, and we denote it by n lowercase I. N1 would be for the first group, or the first observation, N2 for the second, and so on. The relative frequency presents the proportion of times an observation or a group was observed. So it's a percentage or a fraction. And the cumulative relative frequency represents the proportion of ordered data that has been tallied up to a specific value. So you'll see the formula and how it says that we are doing the sum for all groups up to the one that we're considering. We'll see an example later. For example, here's a survey that was conducted on a sample. So we're talking about a little n here of 500 households. And the number of children per household was the subject of the research. Right, so here is a frequency table that summarizes the collected data. In the first column, we have the observations themselves. So we've observed families or households that have 0 to 6 children. The second column represents the frequency, so the number of times each of these observations was noted. So 87 households revealed having no children, 9 households revealed having 6. Those frequencies are then translated into relative frequencies. So these are proportions. So 87 households out of 500 represents 17.4% of households with no children. And finally, the last column presents the cumulative relative frequency. So here we are tallying the observations and including them to one another or adding them to one another up till a certain group. So just to pick one of the examples, let's say 95.2% or 0.952% of the households have 4 or less children. So this would be the tally of the number of observations or the relative frequencies for 0, 1, 2, 3, and 4. When data is continuous, we would proceed by groupings. Now you don't want to have too many different classes and not too little anymore. So we usually are going to make groupings that have 5 to 15 classes. Less than 5 means a loss of information, and more than 15 means that we have too many and it's no longer summarizing the data. So here's an example where we have 245 individuals who revealed their yearly salaries. Okay, so there is a possibility that all 245 responses were different, so we had to group them to avoid having a big list of different numbers. The groupings, of which there are 5 in this case, were placed into groups of size 20,000. There's no need for the groups to be of equal size, but that's the choice that was made here. 25 of the 245 individuals fit into group 1, which consists of salaries going from $0 to $20,000. Since this is a survey, a sample, 245 would be a little n. Once again, the relative frequencies are presented, and this time we have to think of them as the weight of each group or each class. So 10.2% of the individuals are found in group number 1. We don't know exactly each of the individuals' location in that group. And finally, there's the cumulative relative frequency, which would have to go to the right-hand border of each group. So once again, just to pick an example, 91.8% of the respondents have or earn less than $80,000. Data can be summarized very quickly using graphs. So keep saying that a picture is worth 1,000 words, and that's exactly what we try to do when we present data. So we don't want to exaggerate detail, and we don't want to lose too much information either. So the graph that you use should also adapt to the type of variable that you're presenting. Pie charts are used to illustrate the frequency or relative frequency of qualitative nominal data. You should not use pie charts, even though they're cute, for other types of variables. So the area of the sector, in this case, would be proportional to each observation's frequency. Here we have a pie chart that represents the distribution of energy types used for heating houses. So electric, natural gas, and oil have no specific order. There's no meaning to the order in which they're presented. So this is qualitative nominal data. You should use a bar graph to represent the frequency or relative frequency of discrete quantitative data, or also ordinal qualitative data. The bars are usually vertical and of equal width and uniformly spaced. So here's an example where we have the number of children per household that we discussed earlier. And notice how the bars are separate because we want to emphasize the fact that the observations are discrete. Between 0 and 1, there are no other possible values. The bars themselves are of equal width, and they could actually just be lines as well. And the height of the bars are specified for clarity. Now, an improvement could still be made to this graph by using relative frequency rather than frequency itself. Like a percentage is always easier to interpret. Yes, there are 158 households with 2 children, but what does that mean proportionally to the sample size? It's harder to interpret. Histograms are used to represent quantitative data that is continuous and where groupings had to take place. You would like your histogram to consist of between 5 and 15 classes, as we mentioned earlier, and the graphs have to be touching one another because we're talking about a continuum of values. Here are the salaries that are distributed in Granby. So this is, again, data that we presented earlier. So the first group, 0 to 20,000, represents 10.2% of the sample that was observed. The bars are connected, or there's no space between them, because this time the variable is continuous. All of the values between 0 and 20 are plausible, and between 20 and 40, and so forth. Step graphs can be used to represent the cumulative relative frequencies. So here we're seeing the evolution of how many elements or what proportion of elements have been counted. So referring again back to the number of children per household, the cumulative relative frequency would create steps. So no children consists of 17.4% of the sample size. But then when you include no children or 1 child, the proportion goes up to 44.6. And the steps are there for the accumulation of the observed data. Rather than boxes, you can also just use lines. And notice how there's an empty right-hand point because when x equals 1, a step takes place and we go on to the next level of observation. Line graphs are used to represent the cumulative relative frequency of continuous quantitative variables. So this time, because we're talking about a continuous variable, the progression will be smoother. So the height of the curve represents the total proportion observed.